about variables and expressions. This is very useful for translating word problems into equations, which we're going to do a lot this year. As you know from last year and probably before that, a variable is a letter that represents something that can change. An algebraic expression is a phrase, a mathematical phrase that includes one or more variables like x plus 8 or something like that. A variable that could be anything like y, for instance, or z or b. A numerical expression is similar to an algebraic expression, except there's no variables, so it could be like 2 plus 7 or something like that. We're going to try translating some sentences that are in English into mathematical phrases, and we're going to model those and also write down what the expression would be. So if we had 32 more than a number n, we can model the number n, maybe a little rectangle or something, we'll call that n. And then 32 more than that, we can just add another rectangle that says 32. So 32 more than a number n would be this distance here. Whoops. Alright, so 32 more than n would be the distance from this edge to this edge here. And the expression, starting with an easy one, could be n plus 32. Alright, the next expression, we have 8 times the number n. For the model, 8 times n, what you can do is just have 8 n's. 3, 4, 5, 6, 7, 8. And rather than writing n times 8 or 8 times n, we actually write that in algebra as a number next to the letter. So that's 8 times n. And the next example, we have the quotient of a number n and 5. So the word quotient means division. So the quotient of a number n and 5, we can model that by starting with an n. And instead of making it small like I did last time, I'm going to make it bigger. So this whole thing is n. And since we're dividing it by 5, we're just going to divide it into 5 equal parts. And each of those parts is n divided by 5, or n over 5. So you can show the quotient of a number n and 5 by drawing n divided by 5. But this year in algebra, we'll probably be showing it more as a fraction, because a division is just a fraction. So n divided by 5, we're going to show as n over 5. Okay, so on the next one here, we've got a couple things going on in each of these. We have 3 more than twice a number x. Okay, so we have a couple things going on. We have 3 more than, and then we also have twice a number x. So in this case, sometimes I'll start on the back half where it says twice the number x. I know that twice the number x is 2 times x, because the word twice is a specific type of multiplication, and it's multiplication by 2. So 3 more than twice the number x is just 2x plus 3, because 3 more than is addition by 3. For number 5, we have 9 less than the quotient of 6 and a number x. So that's kind of similar to 4, where we have 9 less than and the quotient of 6 and a number x. Now I have a slide coming up that talks more about this less than issue, so I'm going to skip this for now and then I'm going to come right back to it. So let's move on to number 6. Where it says the product of 4 and the sum of a number x and 7. So that's pretty complicated. So we have a couple things going on. We have product and we have sum. So we have the product of 4, so that's one of the things that we're taking the product of. And the second thing we're taking the product of is all of that, okay? So we have the sum of x and 7, which looks like this. Sum is addition. And then we have the product of 4 and the sum of a number x and 7. The way we'll usually write this in algebra, because this looks a little complicated, 4 times x plus 7, and it's also not exactly true. We need the sum of x and 7 to happen first, then we multiply it by 4. So we're going to use that with parentheses. So it's the product of these two things, that thing and that thing. Okay, so this slide talks about subtraction. 58 less than a number n, if we started with a number n, which we could say is this distance here, there's n, and if we say 58 less than that, okay, we could subtract 58 from that, then we'd be left with this amount here. So 58 less a number n, oh, I messed that up. Put that in the wrong parts. Okay, I'm going to move this down here. Alright, let's try that. Alright, we'll get back to that. So if we look up at the top here, 58 less a number n, that means we're starting with 58. And then we're subtracting n, 58 less a number n, and then we're left with that remaining part there. And we write that like this, 58 minus n. I think the reason I screwed that up is because this is very rare. It doesn't happen very often. People just don't talk like that, 58 less a number n. The more common thing that people say is 58 less than a number n. Okay? And this is very tricky. Because although the 58 is coming first in the phrase and the n is coming second, it's actually supposed to be flipped around. So 58 less than a number n is actually n minus 58. It makes more sense when you put numbers in there. If I said, what is 15 less than 20, I think most people would figure out that the answer is 5 there. 15 less than 20 equals 5, and you can see that the 15 and 20 get switched around there. So again, this is a tricky concept. We're going to practice this definitely in class. But 58 less than a number n means you're starting with n here, and then you're subtracting 58, leaving you with this amount there. And that is what I wanted to go back to earlier. Oops. That should have been a 5. I don't know why I put a 2 there. Okay. Getting back to this slide. So 9 less than, again, that's going to switch everything. So that 9 is going to end up at the end, and this other stuff's going to end up at the beginning. So 9 less than the quotient of 6 and a number x. Okay, so we're going to start over here. The quotient of 6 and a number x is like this. And then 9 less than that means minus 9. Okay. So when you are done watching this video, make sure that you fill out the questionnaire below.